In this video, we want to start adding some methods and some operators to the class that we're creating in C++. So we were writing this complex class. It has a real and imaginary part, and we started writing the constructors for it so that we could create an instance of complex. Now I want to add a regular method to this. So something that I might want to be able to do is calculate the magnitude. As with before, while I will put a declaration up in the class itself, I'm not going to write the definition of it there. Instead, I write that in the source file. So I have the return type followed by the class and then my scoping operator and the name. Okay, and then the magnitude of a complex number is simply given by the square root of the real value squared plus the imaginary value squared. Okay. Now, I have a call to square root there. We can compile this. If I just compile it as is, well, okay, first I get the problem with the square root. I would also get the problem that I have no main. We need to include math. I believe this is actually a C library, so I need to include CMath. And we'll probably get the same error. Okay, no, it was able to find the CMath despite the fact that we don't have an STD on there. I do get an error saying that we haven't defined a main, because when I just compile without any -c option, it tries to do a link and it can't build a full application without a main. Compiling with the -c option allows me to actually get this to compile, and it produced this complex.o file. Okay, so we've added a method in here. Now, most of the things that you want to do with a complex number, though, are operations like add. And we could do that in this manner. So we could have a function called add that we pass in another complex to. So we're going to add this and that. And then I could write it down here. However, using the names like add really isn't ideal for when we're putting things that really are mathematical operations. It's nice to be able to use operators for that. And C++ supports operator overloading. So I can write an add like this. So when you're overloading an operator, you say operator, and then you follow it with the operator that you are overloading. And I can come down here and define this. Complex is the return type. Complex is the class name. Operator plus takes a complex of C. By the way, this is not necessarily the ideal way of passing things. We'll talk in a later video about passing conventions and how you should pass things around. But for right now, this will suffice, and it's not too horrible for the complex class. So then I need to create a new complex object that's going to be returned. I can actually do this in a fairly short manner by taking and returning a complex of my real value plus c.real, comma my imaginary value plus c.imaginary. And we can compile it and see that that is happy code. We're not using it any place though. Now, one of the problems with doing things this way is that your first argument to the operator always has to be the type that you're dealing with. And what if you wanted to be able to say, take a complex and multiply it by a scalar? So I wanted to be able to say 3 times a complex number. Well, in that situation, it doesn't work so well to have the operator be defined as a method. You can instead define it as an outside function. Complex operator star, and we'll pass, in this case, it takes 2 complex objects. We'll call them A and B. And it's supposed to return their product. And this can be done in some ways just as shortly. We'll see if there are any problems with this. Whoops, except I'm in my header file. Sorry. So I should just terminate that there. And then over in my source file, I can write this operator. Note, this is not inside of the class, so I'm not going to add a complex colon colon. We're going to return a new complex object. You might wonder, I said the word new there, and if we were writing code in Java or Scala, I probably would call new. New, of course, does return a pointer in C++, but that's not what I want here. This is actually a stack allocated object of type complex. So because this is returning a stack allocated object, I am just going to construct one, and I'm basically, what I'm writing here is a call to this constructor. So when we do the product of complex numbers, I get A's real times B's real minus A's imaginary times B's imaginary. That's the real part, and the complex part is A's real times B's imaginary plus A's imaginary times B's real. Okay, looks good. Let's try to compile it. So we run into this problem here that the real part of complex is private. So when we tried to use it on line 18, it said that we couldn't access it, and it gives us that message for both real and imaginary. And that's what it should do, because these are private members, and the operator is an outside function. It's not part of the class. It should not be able to get hold of those things. So how can we fix that? Well, obviously if I had been doing this, I could have fixed it. It just hit me that I made this a complex instead of a double. It'll work just as well. Though because it's a complex, you could argue that it should be up here as a method. Turns out that actually the style argument is that these things should be down here. The problem is, if you actually have to get access to those members, you have to declare the operator to be something called a friend. And so I am basically just going to paste that up into there. And now this compiles. So what does this mean? Well, you can declare functions to be friends. You can also declare other classes to be friends. And friends have access to private data. As a general rule, you should not use friends. Okay? I like to tell students, friends are bad. Okay, and that's probably going a little bit too far, but this is one of the few times when we'll make an exception to that. If you are writing an operator that is defined outside and that operator needs access to things, you can potentially create a friend class. However, if you're going to be because making a friend breaks the encapsulation, it gives access to the private data to something on the outside, which especially for mutable fields is something that we want to avoid as much as possible. So this would be an argument for potentially moving this up inside. That closes out that video. In the next video, we'll write a little code that actually uses this to see how our complex class works with what little code we've written so far.